First up will be Ben Worel from Minnesota DOT. He has a bachelor's degree in civil engineering from the University of Minnesota. He's a professional engineer in the state of Minnesota. His experience is in pavement research and pavement management. For 7 years, I guess you worked for Braun Intertech, and was involved with the SHRP and the long-term pavement performance project, so that the Strategic Highway Program and the long-term pavement performance. For 20 years, been with the Minnesota DOT in MnROADs as the operations engineer from the day-to-day activities, including research and partnerships with, also including the National Road Research Alliance. He's involved with TRB. He's the chair of AFD 40 committee for the full-scale accelerated pavement testing, and friends of probably numerous other committees there. Currently working with the National Roads Research Alliance to best utilize the MnROAD site for its NRRA customers. He loves his family, his co-workers, and dog Jesse, not necessarily always in that order. So give it up for Ben Worel. Thank you.
Thank you for that introduction. I kind of worried every time he said something, Scott would look at me like, really? But it's a pleasure to be here today and present a little bit on our partnership with NCAT. We've got a good thing going here, and I'd like to kind of share that with you. So again, I'll talk a little bit about the partnership and how it was developed and why it was developed. I'll talk a little bit about the construction that's taken place, and kind of talk about some of the performance of the studies that we're doing. I'll touch upon both the pavement preservation side of it, but mostly focus on that, but then touch upon the HMA performance tests that we're also doing for cracking. And I'll talk a little bit about future work that's coming up as we go forward. So this partnership was one of these things that, if you know Buzz Powell, I think everyone knows Buzz from NCAT. Buzz and I have been friends for a long time through the accelerated pavement testing groups. And we've always said, wouldn't it be nice if we could work closer together? So we finally got our chance here where NCAT showed up in June of 2014 and said, let's partner. And that was great. No one really expected them to come up. It was kind of a surprise, but we've been able to develop a partnership through that and kind of work with our two different test facilities that we have. We have our test facility in Minnesota, and they have their test facility down in Alabama. Again, the idea here is that, you know, they have a hot, wet, no freeze. We have a cold freeze. And if things work in both areas, they would work probably in any place else around in the United States. So we work off the strengths of each other. NCAT's got a great facility, great people. So do we in Minnesota. We talk about operational. We can work on things, do things more similar, work on data sharing, work on the analysis side of it. But again, have a greater national appeal, because these type of test facilities you can't just build any day. I think Minnesota built ours for about $25 million in 1990. Now, if you had to build one, it'd be $80-some million. So it's really tough to build a facility like this in MnROAD, but to utilize it and share it, I think makes a lot of sense for us nationally. So again, we're trying to facilitate high-value research that really our customers are looking for and need. And there's lots of other fancy words in there too, but again, it's getting products out and getting them utilized and implemented. Again, I talked about the two different studies that we're looking at doing, or we started, and I'll touch upon the development of national cracking performance test, but I'll focus on the national pavement preservation study that we're doing. Again, this shows the two pictures, the two facilities. How many people here are familiar with NCAT and MnROAD? I get audience participation there, thank you. So again, the test facilities, I guess for those who don't know, NCAT is a 1.7 mile oval test track. They have 5-axle semi-tractor trailers. They have 5 following each other around, providing lots of loads in a 2.5-year cycle. So they go on like 3-year cycles, but 2.5 years of loading. MnROAD has both a low volume road, you can see there in the picture, but also has a mainline interstate test sections. You can see alongside, there's 3 lanes there, that's I-94 northwest of Minneapolis, Minnesota. So those areas we're able to do different research for concrete and asphalt. National Center for Asphalt Technology is, as you'd guess, asphalt technology down in Auburn. Here's the different sponsors that we have for the performance tests. Again, this is one of the studies that a number of groups are working on. I know New York is here, and Chris has been a part of that quite a bit. And what we're trying to do here for a national cracking study is kind of look at developing a performance test for asphalt mixtures before you place them on the road. The idea here is in Minnesota, we're focusing on more temperature-related cracking, low-temperature cracking. Whereas down at NCAT, they're looking at more of top-down type of cracking, that type of action going on. So there's been a number of tests going on for a number of years, and you can see all different tests there, but which one can you use on during your mix design to actually find the cracking potential or the fracture energy of the mixes to prove a long good performing pavement? Again, we're trying to look at that in the mix verification form, the mix design, but we need kind of a test, because if we don't have this test, there's new products always coming out, and how can you ever test those products or stay ahead of the curve related to those unless you have a performance test to go through and see how that works. That includes like recycled materials, different type of polymers that are being added, and different combinations thereof. What effect does that have on your performance? What NCAT did a couple of years ago, they've been putting traffic on these test sections for now, I think 2 years almost. But they have 7 test sections, 200-foot sections, and they have instrumentation in each one of those, looking at top-down cracking. And right now, those 7 sections, you can kind of see the different mixes they placed. Some of those mixes you would think would have more top-down cracking than others. But right now you're seeing the performance is relatively good for all of them right now. So the rutting, the difference in ride, the beam texture depth, there's all pretty good right now, and the cracking is there's not much, but they still have probably about, I'd say 10 months of loading this year until they take traffic off in 2018. So I guess there's time to see what happens there. What MnDOT did, or Minnesota did, the northern tiered states put together some different designs. And the idea here was that we wanted to design 8 pavements, and we wanted to see how they cracked. And the idea is if you're going to do a test to see how the performance of that cracking is, we built test sections that for like the top one, high crack potential, meaning that we used a 64-22 oil, which we've proven that doesn't work in Minnesota. You get thermal cracks galore, and if you add some extra wrap to it, it should be a very brittle mix. So the idea there is we're trying to build mixes that are going to crack. We're trying to build mixes that don't crack. So farther down on the list, you can see a HIMA mix with a 64E34 with less wrap in it. That should be a good performer. So the idea here is we're trying to build those mixes. We're going to do the lab test, and we're going to see the performance and see how which test actually works out for us. In Minnesota right now, we did a pooled funds study for a number of years looking at cracking, for low temperature cracking, and we kind of came up with the DCT test. Seems to be the best, at least for that version of it, but there's a number of tests so far, and we've been working to kind of work the DCT test into our specifications, but that takes a lot of work too to implement that. But again, this test here, we're looking at other tests again and kind of taking a second round at it. Related to pavement preservation, this started in 2015. A number of states are involved with this, along with the Foundation for Pavement Preservation. And again, here the goals is to utilize the ideas of the north, cold north, and the hot south. Again, these are off-site of MnROAD, so we had to find sections of roadway that was consistent, that we could apply a number of different types of treatments to in a stretch and see how they perform. NCAT did this on Lee Road 159. a few years ago. That was kind of the first case study, going to a quarry down in Alabama. Then they built on US 280 the other year. So Minnesota built the same types of test sections on a low and a high volume stretch. Again, we're pulling together a number of different groups to kind of work on this, but again, it's to provide consistency to the data collection and then kind of consistency to the data analysis to see what the life extending benefit curves that you can get. So when I talk about common activities, again, we're now involved with working with NCAT. We have joint sponsor meetings. We both have pavement management vans or pathways vans that we're utilizing. Just one type of van, but it's consistently between us. Right now, today, they're doing kind of a mini rodeo up in Minnesota. NCAT came up to run our test sections along with our vans, so we're seeing if there's that data consistency. But these vans allow us to do cracking, rutting, ride, and texture. Right now, I'll talk a little bit about the data collection, the amounts, but we're doing every 2 weeks in Minnesota. We're also doing deflection testing, and we're developing common databases to kind of utilize this information to make it available to anyone who's kind of looking at it. We have traffic data, as you'd expect. The analysis is going to be done at NCAT. And again, we worked a lot with the different contractors and designers to develop these mixes and these treatments. Kind of looking at the data frequency that we're working with, you see NCAT, the test track there, Lee Road 159, US 280. Those are all Alabama-based test sections. The Lee Road and the US 280 is off-site. Then we have the MnROAD site and the US 169 and County State 8 Highway 8. That's our low volume. So you can kind of see that for roughness, texture, rutting, crack mapping, we can use with the pathways vans. We do that NCAT's doing it every week, which I think is overkill, but it might not be. We're doing it every 2 weeks, twice a month. And again, Minnesota, you can't really run the van in the middle of winter, so we're running it approximately from April to December. We're also doing manual distress surveys, along with the falling weight deflectometer, surface friction, and noise. So through this information, we'll be collecting, again, similar information, and all this information will be analyzed by NCAT. Kind of talking about the sections that were built and some of the observations. Can anyone say what that county is? I grew up there, so it's like Mille Lacs County. It makes sense to me, but it doesn't make sense to anyone else when they try to read Mille Lacs County. But Mille Lacs County we worked with, we have US 169 running through that, along with the County State 8 Highway 8. And when we did these test sections, we worked a lot nationally, and the people who did the studies down in Lee Road and also US 280, they came up, Vance Brothers, and did the work up in Minnesota. So we had a similar contractor. We had East Alabama Paving helped out, Brock White, Craftco, Coarse, right down the list. Lots of different people to thank for kind of coming up and helping do this work and get consistent materials, consistent product out there, so we could do a good analysis on the data that we collect. But again, thank you for all that helped out. So here, this is one of those slides where you can't see it, but it really looks nice. Someone talked earlier about the different types of treatments, and it's interesting, the chip seals, everyone kind of understood. When you scrub seals and all these other types of seals, the terminology is really interesting just making this chart, because how do you put that down on paper? But again, it shows that the number of test sections, we have about 25 on US 169 and about 25 on CASA 8. And this is the way the sections kind of looked before we started. US 169 was actually a pavement that was maybe a little too far gone for pavement preservation in some ways, but it was a good candidate kind of for reality of what we really are doing out for the state and for the cities and counties. This is a pavement, I forget how much traffic it has on it. It's not a high amount, it's a couple thousand, maybe 10,000 easels or 10,000 ADT one way. But again, it's kind of a squirrely surface. There's some thermal cracks, there's some cracking. It kind of looks like a dry mix, but we did take cores, and that is solid underneath. Whereas CASA 8 was more of the classic, you go 50 feet and there's a thermal crack. You go 50 feet, there's a thermal crack. So you kind of had those thermal cracks controlling there, whereas you didn't have as much of a kind of squirrely cracking happening in the wheel pass. But there's some cracking there. We utilized both the east and west bounds for CASA 8. So this is some pictures. We built these last year, and here's some different things that you can kind of see that's happening. I guess you can use the mouse. You can see here the treatment. This is a scrub seal that started here and went up to here. We're building short test sections. That kind of shows how it's hard to start and stop these types of treatments. So they needed some time to get going before the treatment actually, and it debonded there a little bit. We'll be taking that part probably out of our analysis side of it. But again, the idea is it's tough building these basically tenth of a mile test sections one after another. And so we did see some debonding, some it's construction related, but not fault of the contractor. It's just, again, lots of test sections. Good old snow plows did some damage. This is something that we talked a lot about. You can kind of see the damage there, not as much on the fog line there, the white line. They kept the treatment to save the white line, but you can see the plow that scrapes off the center line. Again, we use underbody plows in Minnesota at times. Typically, they're told to kind of stay off them the first couple years. But this, when you do get ice on the road, they do need safety. So they do work on that quite a bit. Again, only the driving lane was treated. The other thing I guess you can kind of see with that is there is salt, a lot of salt out there and different things. But again, the treatment looks pretty good, and we've been keeping track of the snow plows that are going on it. And I guess here's another interesting thing is that all the treatments on 169, the Thinlays that we put out, some of the Thinlays are they've kind of thermal cracks have come up through about half the thermal cracks. The rest of all the treatments have already thermal cracked through. That's a treatment that was just put down. Again, this is what a lot of the cracks look like. And on CASA 8, when I talked about those are kind of thermal crack, thermal crack, thermal crack every 50 feet, those have all come through each of the treatments so far. And so when you look at some of the ride, here's like the pre-construction, post-construction, and then this April we collected some data. You can see some of the different related to chip seals. So we did chip seals with crack sealing and mastic. We did microsurfacing over chip seals, triple chip seals, double chip seals, Pavement and chip seals. So a number of different combinations. But I guess you can kind of see some of the chip seals as you'd expect. And this is just on CASA 8. And this is the sections that didn't have as squirrely of a surface, but is more just the thermal cracks. And the thermal cracks have pretty much, they still are there, and you're still getting the rough ride through those. We did see a little bit of fix there, the Thinlay over the fiber mat. That one there is actually looking a little better after it's been done. So again, not a big difference in ride, but so much of an improvement in a couple sections. Microsurfacing, this kind of shows the different types of microsurfacing. I think it's a little easier to see here, but a lot of different type of combinations, with different treatments together in combination. But again, you're kind of seeing that we haven't had a real great influence in ride when it comes to microsurfacing either. It stayed pretty much stable with that. But that's not saying that this is also the other aspect of this too is in Minnesota we have kind of seasonal variations in our ride and things like that. So this first ride measurement in April, we still could have some frost action and things like that going on. So it's really maybe a little too early really to make any judgments on these treatments right now. The kind of the overlays, the Thinlays, different types of actions that have been going on. Again, on CASA 8, I'm just showing you those. We had seen kind of improvement in the ride that helped with the thermal cracking. But those thermal crackings that is coming back. So you're seeing pretty much probably the better improvement, but again, this is more costly doing the Thinlays. It's more of an effort to do them, but you're seeing a little more benefit. And again, we need to collect more data really before you can really say anything significant about that. It's kind of interesting too, is you can kind of see some of the Thinlays with some of the readings that we've got where you didn't get as much of an improvement. But I think that might have been, either the milling, kind of the way the milling took place. You can kind of see that variation in the water there. So there's a little kind of a ruffle to it where that roughness is kind of coming through on that. And that Thinlay was not able to kind of go over that and get a better performing roadway. So that's something we need to look into too. One of the things that we were asked to put on our test sections up in Mille Lacs County was an open graded friction course. And this was something that in Minnesota we had a bad experience, so it's one of those things where we're never doing that again. So this is where MnROAD came in. We only have to worry about Doug the truck driver complaining or driving off the road. So we put down, basically we had 2 stretches there of 50 feet each. We did an open graded friction course with a conventional tack on concrete. We did an open graded friction course with ultrafused tack on concrete. And then we did the same type of tack on the asphalt section because we had a section there of both concrete and asphalt. You can see in the right picture. We did this open graded friction course, and I guess it's good to say that after the first winter, it's looking just like it put down last year. So there's some benefits to that. So we have not noticed it icing up or anything like that.
What's an ultrafuse?
It's excuse me, it's a tackless tack, if that makes any sense. I never quite understood that terminology. Trackless tack. Tackless tack. Tackless tack would be really good, but a trackless tack. So, it's something we haven't used. It's very stiff. A lot of the engineers had some issues thinking that that's not going to perform very well. But right now it seems to be working just fine. And here's some of the information from the southern sections. Again, they've been collecting data for a lot longer. You see some of the different things. They have control sections where they had high rutting sections, low rutting sections, high cracking, low cracking. And it's going to take time. As you can see some of these performance, you don't see it dropping off. As we all draw the classic line where it drops off. But you don't see that quite yet, and it's going to take a little extra time to see this. So I just wanted to kind of show that to Southern. They're collecting their data. Their chip seals, again, Minnesota's got 3 points. NCAT's collect quite a few different points. You can see the combinations of the treatments are the same down at NCAT as it is in Minnesota. And then when you start looking at the open graded friction courses, also on the different work that they did on their test sections down there. And again, they're in a different environment to allow those on their test sections. So the idea here is, I think what you're seeing is we've collected 3 points. They've collected a number of different points, and it's going to take a little extra time. I guess when you start talking about the future of our efforts together on this, I think MnROAD and NCAT are going to be working together for a long time on a number of different studies. We're always looking for good ideas if people have those ideas. When you start talking about NCAT, again, they have a national pooled fund study that this is all part of. Again, they're hosting many projects, of which the HMA cracking and the pavement preservation is part of that. In 2018, they're going to be reconstructing their test sections on their test road. And we have a spring sponsor meeting coming up next week. Again, that's kind of a combined effort between our 2 facilities. But again, that's May 16th through the 17th. I know Chris is going to be there. Anyone else going to make it down there? So we got 2. Pete's going to be down there, so that'd be good to see you both down there again. With MnROAD, what we're doing is, I think our future is a National Road Research Alliance. This is our pooled fund. We're going to be doing a number of things through. We'll be doing both concrete and asphalt, and we've started doing that already. We built our test sections for the cracking through NCAT in 2016, but in 2017 we have construction going on for both concrete, asphalt, pavement preservation, and also a lot of work in geotechnical and different types of base materials. So we have a lot of different projects for our long-term research that we're funding through that NRRA pooled fund. We also have short-term projects because NRRA is a part of focusing on implementation. And a lot of the research we've considered is kind of done enough. We can pull those things together and do a state of practices. So a lot of that effort's going to be put in short-term state of practice, kind of common regional things that we're working on through the 6 states that are involved with NRRA. We have a pavement conference coming up May 23rd, 24th. We have a workshop related to that in Minnesota. And also we'll be participating, we'll have the fall sponsor test track conference with NCAT later on in the fall. And that'll be a time where if you can get out to that, we'll be viewing the different test sections that we built on Mille Lacs County. So with that, I'd like to thank you for your time. Again, these are different people that are also a part of this. I'm not sure why Jerry Geib's got a question mark between his name, but Jerry Geib is doing the pavement preservation. I think many of you know him. Dave Van Dusen's leading up the cracking HMA performance test. And Chelsea Hansen's working with the monitoring and working with NCAT and doing the same thing. So I'd like to thank them for working so hard and well on this project also.
I'm wondering if you can describe the DCT test for cracking.
The DCT.
So you had recommended that was probably the preferred test among options, and I just wonder if you could describe it briefly for us.
I guess kind of going into why the DCT test, kind of explain that a little bit, why Minnesota is utilizing it. And what Minnesota did was we did a pooled fund a number of years ago. I think it's probably 15 years ago we started. We actually went through 2 cycles of that pooled fund. And we looked at the SCB test at the time, semicircular beam test. And we also looked at the DCT test. And through looking at both test section data that we had using different mixes from MnROAD, also utilizing different cores that we got from a number of different states, we found that the DCT test seemed to be the most consistent at the time. I think things may have changed a little bit over time, so that's why we're kind of looking at it again. MnDOT has seen that using the DC test and trying to implement it, it's been quite a process. I mean, first you have to get the contractors on board, you have to get them working with it. We found that we did a round-robin testing with different lab testing groups in the state. Trying to get consistent data for DCT is tough. I mean, you have to cut that sample just right, notch it just right, put holes in it just right so you can pull it apart. It kind of looks like the Pac-Man test, if you think of a little Pac-Man sample. So it's been quite involved in trying to get that implemented and seeing if that actually is the right test. Did that help at all? Maybe we can talk later a little more about it too.
What was the application rate on your OGFC for the ultrafuse?
I couldn't tell you. Sorry about that.
Did you guys happen to cut cores on that to see if that material wicked up into the mix?
We've taken some cores. I'm not sure if they're actually done that type of testing or it's more of an observation looking at the open graded friction cores. I haven't seen it. If you had a lot of good experience with that?
No, just
okay.
That's why I was curious.
Yeah, when it's so stiff, you wonder if it does kind of draw up like it should or not.
Yeah, exactly.
I was wondering, you were showing IRI data after these treatments. I was wondering what other performance measures are you monitoring and which performance measures actually show the benefits of the preservation treatments?
I think that's a good question. It actually brings up a good point that maybe glossed over a little bit. Through this analysis, we're utilizing these pathways vans, which is really slick because you can not only take the average for whatever distance you want, like here it's 1/10 of a mile, but we've been breaking those into subsections so you can look at the different types of roadway, and maybe one part of the roadway is farther down on the decay curve than others. So we're kind of pulling all that information together. So I showed you just ride data, and ride is one performance measure that you can use. Rutting is another, cracking is the other, and friction could be another. and so on and so forth, and aging. So those are all those different types of factors are going into the analysis, looking at the life extending benefits of those different types of treatments. So you could have, for example, the chip seal I showed, you could have that chip pull off from the snowplows, but maybe that emulsion is still on the roadway and still preserving the roadway. So it may not look pretty, but the chips are still on the wheel path, still provides good traction for vehicles, safety. But it's going to take time to see those long-term benefits of it. Hopefully that helped. Thanks for clarifying that. All right, thank you.